Today you'll be learning about solving systems using substitution, section 3-2 in your book. Substitution is an algebraic method one can use when graphing is not best suited. You can use the substitution when it is easy to isolate one of the variables, or if in the example we have here, you already have a variable that is solved. By isolating a variable, you can substitute for that variable into the other equation. Like on this one, you can take 2p plus 1 and plug it in for q, since it's what q equals. So that it would look like this. 4p plus 2 times 2p plus 1 equals 8. So I plugged in what q was. So we substituted the second equation into the first in place of q, so that now we only have one variable to solve for instead of two. Let's look at how to do this. Solve by substitution. Here's an example. 3x plus 4y equals 12, and 2x plus y equals 10. First step, we're going to solve one of the equations for the variable with no coefficient. Remember that a coefficient is the number in front of the variable. So the only equation that has no coefficient is the second equation with the variable y. So we're going to take the second equation, 2x plus y equals 10, and we're going to solve for y by subtracting 2x, so that y equals 10 minus 2x. Second step is we're going to substitute that answer into the unused equation and solve. Since I used the second equation in step 1, then in step 2 I have to use the first equation, 3x plus 4y equals 12. And I'm going to plug in what I found in place of y, since it's what y equals, so that we get 3x plus 4 times 10 minus 2x equals 12. Then I would go about solving this equation by beginning to distribute the 4 first, so that 3x plus 40 minus 8x equals 12. Then you can subtract the 40 and combine like terms. So 3x minus 8x makes negative 5x, and 12 minus 40 equals negative 28. Then we would divide both sides by negative 5, and x would equal 28 over 5. Third step is to take that answer and plug it into the equation from step 1 to find the remaining variable. If you remember, we found that x equals 28 over 5. And the equation from the first step was y equals 10 minus 2x. So now what we're going to do is we're going to plug in 28 over 5 in place of x. So we get y equals 10 minus 2 times 28 over 5. Make everything fractions, and we would get y equals 10 over 1 minus 56 over 5. To subtract fractions, we need to multiply the first one by 5 to get a common denominator. So now it becomes y equals 50 over 5 minus 56 over 5, which equals negative 6 over 5. Write your final answer as an ordered pair and check your ordered pair. So our final ordered pair, we would take 28 over 5, comma, negative 6 over 5. To check it, I would plug it back into the equations from the original problem. So we could do 3 times 28 over 5 plus 4 times negative 6 over 5. And we want it to equal 12. So we would get 84 over 5 minus 24 over 5, which would equal 60 over 5, which does equal 12. So that is true. If we plug into the second equation, we would get 2 times 28 over 5 plus negative 6 over 5 equals 10. So we would get 56 over 5 minus 6 over 5, which equals 50 over 5, which is 10. So that is true as well. Therefore, 28 fifths, comma, negative 6 fifths is my answer. Now you try. On page 142, got it number 1 in your textbook. There is no more after this. This was the only thing you will be taking notes on today. So after you try the got it and check it in the back of your book, you are welcome to try the 3-2 assignment.